welcome back to the shop, everybody. Today I'm going to start a small project to upgrade my lathe, and that is to strengthen the mounting of my quick change tool post. As you can see here, this is the tool post itself. It's AXA sized, and then the top of my compound. Got a ridiculous nut here, so it takes a little bit to get it off. Here you can see the stud. And then, yeah, you can see that. This is the bottom. So how this is held in place is just a recessed boss with an offset hole that a roll pin goes through, and that prevents the stud from spinning. And then the boss itself holds it from pulling through the top of the compound. The issue with this is, as you can see here, there's kind of a discrepancy in size. I'm assuming this was so that when I bought this, this was designed to be a, just put it in place, no modifications needed, quick change tool post. So here it's 10 millimeters, and then here it necks down so you can use an M8 thread. And then you can see here the nut that spins all the way up on it, that's considerably bigger in dimension. It's got a large hex head that's 19 millimeters across the flats. And that's the problem, in my opinion, because as you can see, a 19 millimeter wrench is not a small wrench. And it's way bigger than what you would normally use to tighten down an M8 bolt. So over the years, I have broken several of these studs, always snapping them here in the threaded area, mainly because it's weak. So what we're going to do to remedy this and potentially maybe increase the rigidity of the lathe is to make a better stud. So it's going to be 12 millimeters in diameter across the entire length, and then it'll be threaded M12. And then I'll make a custom nut to go with it that I'll mount on top of the quick change tool post. So to do that, you obviously have to make turn a metric thread and a metric nut. And then I'm going to have to go in. We'll have to bore the counter bore out to size so it's bigger. We'll have to bore the through hole out to size, and then we'll have to drill a new hole at a different location for the roll pin. Nothing complex, nothing overly difficult, and nothing that requires a high amount of accuracy. It's just kind of a general, small, nice little project. So let me reposition the camera and we'll get started. So I'm going to start off by making the nut because I have a tap to do that. And then I will just thread the stud to fit it. This is just some cold rolled 4140. Face off, drill, and then tap. Now that the nut blank is faced, I've gone ahead and slowed the lathe down, and I'm going to drill it and tap it. While I'm pretty sure I've never used this tap before, it's not exactly a great one. It's an old high-speed steel Sears and Craftsman one that I got quite a while ago. And I don't normally tap metric this big, so I'm going to definitely need to use the crescent wrench trick to get this to go through. It's going. Not very well. There, we're through the bottom. Because it just got a lot easier. I've gone ahead and made this mandrel off camera. It's nothing more than a piece of scrap bar stock turned down to 1 inch in diameter and then faced, drilled, and threaded for M12. And then it just has an M12 bolt that was Loctited in place and then the head machined off. And since I used this bit to do the facing and I have my dial indicator set up down here, I know the exact distance this cutter tip is away from this face at any time. And what that will let me do is thread on the blank I made previously. And now I can face this to an exact length because I know the distance from the mandrel to the cutting tip. And it also gives me access to turn this down to size because the mandrel is smaller than the OD of the nut will be. And the last benefit of this method is that because of the way the threads work, it's self-tightening. The only way this is coming off is if the Loctite lets go, which is unlikely because there's almost 1 inch of threaded stud in here that's all Loctited in place. So with that being said, let's get started. Now that it's down to thickness, I can turn it down to the proper diameter. Well, at least the largest, most diameter. Got to remove my stop here. Take a quick measurement here. Final diameter, this is supposed to be 1.102 inches. And I'm almost at 1.35, so I got quite a ways to go. see if it's in tolerance. And it is. So the next step is to turn a smaller diameter on this end so that when I go to mill the hex, I don't have to remove as much material. To do that, I'm going to need to switch out tools and set a different stop. Okay, final cut will be 8 thousandths off the radius. Once I came up to the shoulder, I wanted an extra 2 thousandths to bring me to my final length, and then I faced out the, I don't know, I guess the face. Next step is to just chamfer everything, and then part this off and go to the mill. Okay, I'm over here at the mill now. I've got the blank on the mandrel set up in a 5C hex collet block. I've got my magnetic stop set up so that when I rotate the block, everything should come back. I've touched off, so all I should need to do now is take a couple passes and get a baseline measurement and then go to town. I've got to take 7 thousandths off each face. So the first thing I'm going to do, just so I don't lose my place, is put a mark on the face I'm starting with. Make sure I'm up against the stop. No cutting fluid. And that's the last side. So let me grab a wrench and see if this fits. There we go. I have to come back and put a little chamfer on that, but all I did was put the tool bit at maybe a couple degrees, 2, 3, maybe max, and just came in and cleaned up a little bit of the marks that were left by the end mill. Almost. See, that was too much. That was kind of a... That started chattering, but it did get it. It doesn't look that bad. We come back and retouch this one more time. And that's it. At least I can break this loose. Yeah. There's one nut. All I have to do is deburr it a little bit. I'll chamfer the inside of this and then it's done. So the next step is to actually make the stud. It's been a couple days since I made the nut, and that's mainly due to the fact that the time of the year and I'm got lots of family obligations, but I'm in the shop now, so I've gone ahead and changed my mind about using 4140 for the shaft. The stock that I have is just way bigger than it needs to be, and I didn't feel like making a crap ton of chips. So I switched over to this is 1144 Stressproof. I've already turned it down to the major diameter of the studs. The next thing is to go ahead and remove a large amount of material off the rest of the shaft. So I had to go ahead and do a little polishing. I went at it with some 200 grit sandpaper and then some of the 360 grit Merlon that I have, because when I finished that last cut, I was about 0.5 thousandths over diameter down here and right at the very end. So, and this is going to get turned down and threaded, so it's going to be undersized a little bit anyway, which I don't care about, but this needed to be brought down to spec. So the next step is going to be to set up my stop here, touch off on the end, and figure out where I need to put my thread relief. So I've gone ahead and off camera sharpied up the threaded area and then did a light pass to validate that the pitch was correct. And I'm probably not going to talk a whole lot during this, because to me this is probably the most difficult thing to do on a lathe, because I'm turning a metric thread on an imperial lathe and I'm essentially doing it between centers. So to do that, the method I'm going to use is what I've heard referred to as quick draw. The half nut's going to stay engaged at all times, and then when I get to the thread relief, I'm going to quickly retract the cross slide and turn the lathe off, and then to get back to my starting point, I'll reverse the feed back, feed the cross slide back in, and then reset the feed direction to go towards the headstock again. So let me dial in a cut of 5/1000 on the compound, and we'll get started. I will apply a little bit of cutting oil now. Oh well. So it goes on, but it's a little too tight. So what I'm going to do is, what I'm going to do is I'm not going to use the compound anymore, and I'll just use the cross slide to take the last thousandths and use the cutter as a 100% as a form tool. Double check everything because I'd hate to screw it up now. Going towards the headstock, everything's set. Yep, good to go. Let's see how that did. No rock, nothing. Nice clean thread. I took the liberty of going over to the bandsaw to take off a big chunk of the material that was back in the jaws. So I still have quite a bit to come off, maybe 150 thousandths or so, but it's not like 3/4 or 7/8 of an inch. So that's less work. And then the only other thing I want to point out is because the diameter of the stud is actually smaller, or I believe it to be smaller than the diameter of the little arcs cut into the front of the chuck jaws, I shouldn't actually get any marring in March because essentially the chuck jaws aren't biting with the corners, they're just kind of squeezing with the middle. So it's not a great hold for, per se, but it's more than enough for this task. that should have been the final pass. Take a quick measurement and verify that. Yep, in spec, it looks like it's shooting for 180 thousandths plus or minus 5, and it's 1/10 over? 2/10, no, 1/10 over. So good to go there. Switch out to a chamfering tool. We'll put a little chamfer on this, and it'll be good to go. Next step is to go over to the mill. The stud is now centered underneath the mill spindle within 0.5 thousandths or so, so that's plenty good enough for this type of work. This was a slightly interesting setup because, one, I didn't want to damage the finish on the stud, and then two, I didn't really have any common ways of holding it vertically like this. I don't have any metric collets, so none of my collets were close, so I couldn't just drop it in a 5C collet and stand the block up. So what I ended up doing was I put 2 V-blocks on top of parallels that are offset a little bit because the stud's so big that it barely fits down through the parallel and clears the vice jaw. But they're in place now, they're down good. Stud's vertical. So now all I have to do is offset this and then drill the hole for the roll pin, which is going to be a 3mm hole. And the offset is 350 thousandths. So let me do that real quick. Adjust the dial here. Oh, it's the wrong way. There's 1, 2, 3, 50. There we go. Now you probably can't see, but I have a dial indicator off the back reading off the table itself, so. And there's that. That looks about right to me. So this is a 1/8 inch spotting drill, which should be more than enough to set up for the hole. Let me get some cutting oil first. Never have enough cutting oil. And that's really all there is to make this stud. So I'm going to take this over to the bench. I'll deburr this hole. I'll test it with a roll pin. I'm sure there's some, there's a burr on the other side. And then it's on to the compound top, which is all going to be done over here at the mill. That should be good enough for now. It's within a thousandths, and that's considering there's a lot of wear on this surface, so it's really kind of hard to gauge what's square. So the next thing is going to be to get this stuff out of the way for a second, get the spindle lined up, and then try and get the spindle in line with what is the current bore through the compound. So everything's now set up. I've taken one light test pass just to make sure I had no rubbing, because this is kind of a tight fit with this boring bar down through the boss here. But looks like everything clears fine, so now I can take some cuts here. I did a quick measurement, but I haven't completely cleared up the bore all the way down through. But it looks like I got another 60 thousandths or so to come out, so it'll take a couple more passes. Kind of hard to do this down in such a tiny hole. Hopefully this should be the last pass, taking out 3 thousandths. Come back up through here, and I'll run another spring pass. Good measure. And that's within tolerance. It's about 1 thousandths, a little over about 11 tenths over the diameter of the stud. So now the next step is to go and remove this boring bar and put in this special one that I ground. So it probably won't show up on camera, but this very tip, maybe the last 1/16 of an inch or so, is perpendicular to the axis of the. So when I go down through here and make little tiny step overs, it should flatten out this rough bottom, hopefully. This I'm going to do by hand. Still got a little spot back in that corner that's not cleaned up yet. So 75% of the way through, now that I look back here in this corner, which isn't completely cleaned up yet, I'll bring you guys back when I've got this all cleaned up and I'm coming down to size. So I'm down to the last 6 that needs to come out. And I'll show you how I've been measuring this. So this is just about deep enough that you can use some spring gauges. So what I've been doing is, you can't really pull them, like in the normal sense. So I've just kind of been putting them down in, wiggling them just a little bit and letting them find their center, and then pushing down and tightening ever so slightly so I can pull them out. And I've been getting very consistent readings within a couple tenths each time. So I think that's good enough. So let's make this last pass and see how it goes. And that's it. So let me clean this up, take another measurement. And that is where it needs to be. So the next step is to pop this out and put in a special tool that I have for making chamfers. So as you can see, it's nothing special, it's just a regular bit. There we go. You still have to get it in the machine properly. That will clear, yes. So all I'm going to do is run this down and get this inner board and just put a little chamfer on it. And I'll bring it up, and then I'll do this outside one as well, so there's nothing sharp to cut myself on. Let's make sure we clear. Running into the dovetails would not be fun at this point. And it'll clear, which is good. That's it for that. The only thing left to do, well, once I run this back in, is to go ahead and drill the hole for the roll pin. Let me clean up a little bit and then we'll do that. So here it is one more time. The old one and the new one. And then the old weird looking nut and then a more standard looking flange nut. So this drops right in. I'm not going to put the roll pin in for you guys. That's going to be an annoying task, so I'll do that off camera. Just like that even. And that's how it's going to go. So let me do this roll pin off camera and I'll bring you back when I get it remounted on the lathe. So the last thing I quickly did off camera was I went ahead and I sawed off the last little bit of the stud that had the center drill hole in it. And then I mounted up the forge jaw real quick. And then I just went to town with a file and some sandpaper, get it down nice and close like this so there's nothing sharp here. And I have to say, having gone ahead and tried this now a couple times, it actually feels like, tight. It doesn't feel like, if I just pull on this a little bit harder that I'm just going to snap it. Like, it's not, I've got this locked down as hard as I think I would normally ever want to pull on a wrench like this. And it feels completely solid, like nothing's going to break it. So I'm really happy with that. Over time, we'll see if there actually is any extra rigidity or not. That's to be seen. Maybe on the next project, I'll see that. Thanks for sticking around. Hope you enjoyed it.